Good, good morning, Alyssa. Thank you. And thank you for being so prompt. I know you were here at, anyway, good morning. More people coming. Why is this not working? And good morning, Lakshmi. Also, thank you for being so prompt. Also redundant on my part to say, good morning, Charlie. Wait, and I'm, hold on, and there's somebody else here and I can't let them in. Oh, yes, that's Jayla. Okay. Good morning, Saad. Thank you for saying so. Oh, and oh, we're actually having real people fly. Oh, and good morning. Oh, I won't jump the gun, but good morning, Vivian and Jayla. That's awesome. And I don't mean to jump the gun. Wait, and good morning, Daniela. And good morning, Daniela's emoticon or emoji. Wait, I know there's a different, oh, get back to, yeah, that's like a hard vocabulary thing for me, emoticon versus emo. Anyway, good, and there is, okay. Awesome, awesome. So, okay, yes. Good morning, Alyssa. Good morning, Lakshmi. Good morning, Charlie. Good morning, Soad. Good morning, Daniela. I totally, yeah, in particular, oh, good morning, Julian and Charlie and Newell and Jayla for being so live and live. Oh, and even with, oh my God, Jayla's on the jaywalk. Are you on the jaywalk? Are you outside? Oh, that's cool. And no mask. I get it. And Julian is clearly like in the building, which is also cool in a totally different way. And I like the map. Okay, yes, I shouldn't be calling attention to people. And Charlie's in the building. No, not in the building. Why am I doing this? Sorry, not. All right, I'm just trying to acknowledge people's humanity. I'm not trying to like, okay, that's so awkward. All right, so who else do we have? All right, I think we'll start a minute. Is that everybody? Okay. And I hope it's increasingly always clear that I'm just trying to acknowledge people who are here. Like if someone's not here, I don't know who they are. This is not secret attendance, I promise. Okay. But we do seem like no, people are coming. Okay. We will start in a second. Usual disclaimer, you guys are still ahead of me. I'm behind you. That's a good thing. I mean, hopefully you're getting stuff back from me. You're getting your game things, but I still have more game things to return. I still have more homeworks to return. As long as you're always one step ahead of me, it will come out of the wash, I promise. As long as you're getting anything from me, you know I haven't abandoned you or walked away fully. A quick also note while we're just waiting for a couple other people to come in. Wait. Oh yeah. Oh, and thank you for being here, all of you. I almost should put this in the portal. You get special thanks for being here today because I know that there was major confusion whether today was today or not. Like there was a panic. Yes, I maybe some of you might not be aware, but like a schedule was posted that said today there were no classes and that tomorrow was, which was a complete mistake. And like, but it caused chaos and it rippled through my department. And so if you figured out that you are supposed to be here today, Quark, bless you for doing so. You are in the right place. Okay, we're going to start. I'm going to stop stalling. Just hello, Farouk. Good to see you. Who else? And there's a hello. There's a literal black box. That's mysterious. There's like actually a black square with nothing written on it. That is like, okay, the shadow. Oh, no, that's, no. Oh, it's Vivian. Okay. Anyway, so we're going to start. We're going to keep going over physics. Oh, one quick note. You will notice that one new, first of all, any of the game portals that were due October 1st, remember, don't stress, like October 1st is sort of arbitrary. Those are just ones, those are all just like, just check them out and see if there's any time you've ever used your voice or shown video. I mean, a lot of you are doing this, but just, I hope it's increasingly clear that all these game things are just like grab points when you can. Anything you've done that you think that you qualify for that reward, just cash in the points, so to speak. And if they're due October 1st, that's just a way of saying like, these might be one-offs for many of us. Like we might one time use our voice. So we just use that portal because you don't have to use your voice every day or something like that. So don't get overly worked up over the fact that they say they're due October 1st. But so I just put in a new one like that. You might have noticed like 5 minutes before class, I put in one that's due November 1st. And again, you can use it multiple times. I mean, again, it's just to distinguish it from the daily game turns. But the one that I just put in, and I know it applies to at least one of you in this room, like it's 11 points. And again, not to make you obsessed about points, but the one that I just put in, that's called like be wrong, be really, really wrong or something silly like that. This is almost necessarily a double or triple dipper one. Like if you use this one at all, you probably are also getting points in other portals for the same thing. So let me back up for a second. Please note that there is a portal already that has been up that some of you have used. There is a portal that says a game, something for right or for wrong. I mean, like it's been up there since the beginning. Again, just calling your attention to it. Some of you have used it. Some of you might not notice it's there. One of the ones that's due October 1st says like something for right or for wrong. And that's a little confusing. I'm sure it was confusing right when we started this class. Let me just remind you of what that means. And again, remind you, it could refer to something you did 2 weeks ago, as long as you remember. That's anytime you have actually said something or chatted something concrete enough, like gutsy enough, specific enough that I either responded, that's right, or I responded, that's wrong. But like, in other words, not just some vague thing, like, not a vague thing like, can you repeat what velocity means? But something like, I think the answer is 7, or something like, I think there needs to be a negative sign there, or whatever. If you said something concrete enough that you took the risk of possibly being wrong in public, right? If it was right or wrong, if I said either thing, if I said that's right, or words that or that's wrong, then you totally can put that in the portal that says for right or for wrong. Like I'm trying to say, let's all have guts, let's take risks, whether it's on exams or in a class. So anytime any of you have said anything concrete enough that it warranted me saying right or wrong, you can put that in the portal for some number of points that's called for right or for wrong. But now, okay, technically that's old news. But now what I just added today that ups the ante a little bit, and again, this is just an incentive for those who choose to take advantage of it. Now I'm putting in I put in a specific portal that says specifically be wrong, be really, really wrong. This is for any time that you say anything or you chat anything that was so concrete and so gutsy or whatever, or so risky that I literally did have to say that that's wrong. Hopefully I said it in a polite way. Hopefully I didn't shame you or whatever. But if you said something and I said, no, that's actually not true, I want you can still put that in the other portal because it counts as being right or wrong. But I'm saying now you can double dip that same entry. You can put it in the portal that says be wrong, really wrong, because I literally want to give you guys points for being wrong, if that makes sense. I hope it does. Like, and you might even say, wait, now aren't we just all going to go out of our way to like say stupid things all the time? And like, won't we just like be carelessly wrong all the time just to get points? Good luck. I dare you. Like, I'd love to see that happen. I don't even think it's going to happen. I don't think, but if it does, great. I'm saying it's so hard for John Jay science students to actually like be wrong in public. And it's such a habit that we want to enforce. And particularly on Zoom, it takes so much guts to say something that the professor might say it's wrong. And also, as we all have, I'm sure, picked up on this point, I'm such a chatterbox, or I'm so vague in a way. Like I have a hard time just staring someone in the face saying, you're wrong, you are wrong. So if you say something specific enough that it actually forces me to actually come out and admit that you were wrong, again, hopefully I did it politely. But but it's almost to reward me too. If we can both have that clear of an interchange in public where you contribute something and I say, good point, but no, or whatever, you get 11 points for that. I want to encourage people taking those kind of risks. I'm even going to go out on a limb right now and make an example. Like I'm going to just to show you, and I'm saying this as total praise to a person in this class. This is, and I'm taking a risk doing this. I hope it doesn't embarrass a person or whatever, but like I mean this portal so much that even if you phrase something in the form of a question, even if you hedge your bets and like, is it 7? Like, even though you're technically asking a question. So technically, if I go, no, it's not 7, like technically you're not wrong, right? Because you said, is it 7? So there shouldn't be any shame in me going, no, but good question. Well, even that you can get 11 points for. Like, even if you phrase it like a question, if I somehow was forced to say like, good point, but actually no, you get 11 points. And here's the example where it did happen last week. And I'm saying this as praise. When I believe it was Jayla, when Jayla like wrote in the chat, like, shouldn't the units be meters per second squared? She was also gutsily, almost like very politely correcting me. She was like, wait, isn't it possible that you made a mistake, prof? Which is a good, like, thing to do. Like, obviously, if people argue with me all the time rudely, maybe that's bad, but to actually be paying enough attention to be like, wait, I think there's a mistake somewhere here. Like, that is so good and so hard and so important. And it was so good and so hard to pay that close attention to units and to actually know that there is a thing in physics that's meters per second squared, even though we haven't gotten to it. Again, praise be to Jayla for doing that. And I want to say that specifically, Jayla can take that, and anybody else like who does this, and other people have, I'm just remembering this happened last week. Jayla can take that contribution and put it, one, in the portal that says for right or for wrong, because it was like either one. And she can also take the same entry, and should take the same entry and put it in the new portal that says like be wrong. Like, that's a ton of points for being wrong. That might strike some of you as weird. Good, like it is, but it's for a reason. Like, the more, anyway, if nothing else, it's to like reward engagement. I think this class is very engaged. I think if I shut up, you'll even talk even more. So I will shut up about this. I think it's clear. Like, put any questions in the chat if it's not clear. Okay, I'm gonna look in the chat. Wait, cool. Okay, wait. So thank you, Jayla, for saying that. And thank you for, okay. And seriously, cool. Thank you. And by the way, not to be weird, but the fact that Jayla just put a thank you in the chat, besides the fact that that was like very polite of her, that also counts as closing a conversational path, or whatever I called that portal. Like, because she's also like acknowledging that she heard me and I heard her and it's all right and nobody died. Like, so that allows me to move on without worrying about her for the next threat. So that's a triple dip, that's a quadruple dip. She can put that in just for her participation for today, just her general game turn. She can like, you know, and then the same thing that she typed up for game turn 7 or whatever it is, she can literally put in those all those other portals. It counts for all of them. Like, this is all, and nobody's punished and nobody's saying this is just all about, we're trying to just reward and reinforce practices that I not only like for the class, but honestly, deep in my heart, why I spent so much time on this with all of you is I think these are the practices that really make for great science researchers or higher science academic. If you're trying to get a job, if you're trying to go to graduate school, if you're trying to work for the police after this, if you're trying to work for the government, like, honestly, what separates the real scientists from the fake scientists, I think, in my arrogance, I think what separates the real scientists is that they know how to experiment all the time, not just in the lab. They know how to experiment with their voice, with their brain, and in public. They know how to take the risk to make mistakes. Like, that's what a real scientist, and they know how to not know something and be okay with it. So I wouldn't do all this if I didn't think it was like really an important practice for your next steps in life. But okay. Now Daniela's question, also a really important question. Frankly, I want to count this also. She can totally submit this for all the exact same things I just said about Jayla. Even though it's not physics, but it's logistics. No, there was a big mistake. Like, the fact that you all are here, again, praise be to you. A schedule did strangely come out on Sunday. I know what like Danielle is asking about. She is not crazy. A weird schedule got posted that only people that pay attention saw, but a schedule got posted by the registrar or whatever, by CUNY, John Jay, that said that we don't have classes today and that tomorrow follows a Monday schedule, or thought. It was completely a bizarre registrar brain fart that they are totally like scrambling to retrieve. I think they did retrieve it. I think like 2 hours later, they put out a new revised schedule and said, oh my God, I'm sorry. But they couldn't pull it off the web like fully. It's just literally a mistake. I've never seen a mistake that blatant happen at John. And it sent my department, believe me, I was getting emails all day from my adjuncts who thought they didn't have to work today. But no, it's just literally a mistake. Today is normal. Tomorrow is normal. If you think today is not normal, it's not your fault. You're not crazy, but it is a mistake. I don't know how it happened, but it happened. So that totally good question on Danielle's part. If she heard me and if she writes, got it, thanks, whatever, then she gets more points for closing a conversation about. But all right, I hope you're all clear on that. Today is normal and tomorrow is normal. Obviously, if you're here, that's already good. But yeah, and if I were the type of person to punish people for not being here, which I'm not, like I would definitely not punish anybody for not being here today, but hopefully they'll see the video and the notes. Okay, right, is that cool? I just forgot, I just put that away. Oh, Daniela, is that cool? Oh, okay, good, thank you, cool. All right, we are moving on, back to physics. Yay, okay, back to physics. Boom, right, okay. Okay. So this is probably hard to read. It says reference frames. You mean how speed and velocity are relations, not properties. We have to get to acceleration soon, as Jayla and others like sort of implied last time. We have to move on. Like there's more to physics than just speed and velocity for sure, but they are speed and velocity, particularly velocity, is like the keystone or the cornerstone, the foundation of physics. And there's, for good or for bad, there's more that we have to deal with average velocity and average speed. We have to get in, we really have to unpack them even more before we get to acceleration, which is where this train of thought homework is going to come in. We're about to start going over that, which also means soon I'm going to assign a new homework, sorry to say. But it won't be due Wednesday because we're still off to catch up with each other. But I think by Wednesday, I'm going to assign something new for next week. So we're going to get to the train of thought homework today, which looks like a lot of English. You did it so long ago, you might barely remember. It doesn't look like a lot of numbers. It seems like a weird departure. It is meant to help us unpack the notion of average speed and average velocity in an important way. Okay, but before we do that, so that's what this is all. So it gets us into reference frames and the relational quality of velocity. It turns out velocity is a relation. It's a comparison. It is not a property of an object. Like it turns out, I mean, just to where we're going to go today, we'll hopefully start getting to today, is that velocity is not like temperature or mass or something. It's not a characteristic that an object has. It's a characteristic that an object bears in relation to another object. In order to have a meaningful velocity, you need two objects. You can't just have one. You can have just one to have a mass. You can have just one to have a temperature, but you need two objects to have a velocity. That's like which affects calculations a lot. That's where we're going to get to today. That's where this is going. But first, I think we have to finish one problem, I believe, from the end of homework 2. I think we had one more problem to do. I'm going to do it sort of quick. I'm going to do it sort of quickly, but because where we ended last time, remember, we ended at the average speed for a hill figure. I'll just say this. Where we ended last time was if you go up the hill and down the hill, if you go up the hill at 50 miles an hour, if you go up the hill at 40 miles an hour average and you come down at 60, and there's no tricks or nothing else going on, we determined that the average speed for that round trip of 40 and 60, that the average speed was not 50, but in fact 48. And I really do want, if there's any questions or further probings or confusions on that, you should definitely ask today. We're going to do one more problem that looks at the same type of issue. So it's not too late at all, but you, in your heart of hearts, don't let me go on and don't you yourself go on. If you're not clear and confident in your mind why the answer is 48, not 50, you don't have to be clear and confident that you would have gotten that yourself the first time. It's okay if you didn't, but you should see now why it's right. And you should see now why 50 is wrong. And you should see now why it's fair, to be honest. Like at 48, it's not a trick question. If you really understand what we're doing so far, and you might have to keep looking at it, you'll see that it's 48, not because we did some weird thing to figure it out, but we just did exactly what we're supposed to do to figure it out. And if we got 50, it's because actually we panicked and didn't figure it out the correct way, if that makes any sense. But now we're going to see that again sort of quickly if we do the last problem on homework 2, which is called GrammaGrimm, I think. And again, stop me if I'm like off base, if I'm in the wrong place, but this is where I think we are. I'm probably not spelling things right. I don't remember if it was Roman numerals or not, but okay. So I'm going to do a diagram. I'm going to do the facts. I'm going to do the question. I'm going to try to do it quickly, but if I recall, and stop me. I'm not looking at the sheet right now, so stop me if I'm getting something wrong, but I believe it was like 80 kilometers. No, yeah, to grandma's house. right? So again, stop, I'm looking in the chat to stop me, but I think this is my diagram of the facts of the problem. It's also sort of implicitly the question, right? This is like step one, DFP, diagram fact pattern. So I believe we've written Little Red Riding Hood. It's 80 kilometers to grandma's house. That's the distance, or that's the displacement is positive 80. Well, yeah, that's the distance. Then, and we're told that she goes at an average speed of 40 kilometers per day, right? Odd units, but totally legitimate units, distance per time. Then she comes back the same trail. We assume she takes like negligible amount to turn around. By the way, that's not a ridiculous assumption. It just means that the amount of time she takes to turn around is so small that it can't be picked up on whatever clocks and measuring devices we used to measure this whole journey, right? Which is actually totally reasonable, very scientific. I'm going to talk more about that as the class progresses. But whenever we say negligible amount, we don't mean Smurfville. We don't mean something idealistic or impossible or unrealistic. We just mean something immeasurable. We just mean that it's whatever measuring stick we use to measure 80 kilometers, right? Which would not be like a micrometer. It wouldn't be like calipers or like a microscope, like whatever you're measuring, whatever tool you're using to measure 80 kilometers would be like a yardstick or bigger, right? So and whatever clocks you're using to measure days, I mean, it might even be a calendar, but like, it's not going to be like a stopwatch that measures milliseconds. It's going to be like, 1 o'clock, 2 o'clock, 3 o'clock rock, like that kind of clock. So we're just saying that the amount of time and distance that she takes to turn around is so small that it doesn't get picked up by those measuring tools. Okay, so it doesn't count in our calculations. That's why this is science, not math. The amount that, okay, so she takes an immeasurable or unmeasured amount of time to turn around. She comes back the same 80 kilometers back. And we don't know how fast she comes back. In fact, that's not a given. In fact, that's what we're going to try to figure out. We're going to try to figure out the average rate at which she comes back, such that, last fact that is given, such that, well, this is totally illegible, sorry, such that the average speed, I should say, for the entire round trip, oops, sorry. So I should really say the average, like the average speed, there's not really, I'm trying to, anyway, the average speed for the whole thing is 80 kilometers per day. That's a given. And it's 40 kilometers per day on the way out. So we're trying to figure out the average speed on the way in, right? So this is my diagram and fact pattern. That's step one of the process. I'm turning the page. Tell me if you want me to go back. So that was step one. I'll even say, just so we're keeping track, still learning how to do problems the Verdun way. So that was diagram and fact pattern, just side note. And then as for what is the question, right? I mean, I sort of wrote it on that page already, but the question is, well, I'll be more specific. Oh, sorry. Right, so this is the question, just to be sure. And again, I'm being a little bit, once we're really always about velocity and stuff, then I'm only going to use the equations and the notations. But when we're talking about speed, I'm keeping it a little bit in English sometimes because it's hard to do the notation. But okay, so I hope you all agree this is the question. What's the average speed for the return trip, which I'm also calling the in trip, so to speak? What's the average speed for the in trip such that the average speed for the whole round trip is 80? And another given from the other page was that the out trip was 40. Now, well, the first thing, so that's okay, just to get it out there, one's instinct for the answer to this might be 120. Some people in their homework did put that. Like, I totally understand that. It might be the single best wrong answer possible, or it might be the second best possible answer. I totally understand why people put 120, because, and you're not crazy. You're thinking one leg is 40. We want the whole thing to be 80. So the outer leg, one leg is 40. We want the average for the whole thing to be 80. So the other leg should be 120, you might be thinking, because you might be thinking the average of 40 and 120 is 80. You'd be right about a lot of those facts, but it's not the answer to this question for the same reason. Like this is really the same problem as the Hill figure problem, only we're just reversing it. There, we gave one leg, gave the other leg, asked for the average. Here, we're giving one leg, giving the average, asking the other leg. We have to realize that the same concept is operating here, which is that average speed does not mean the average of the speeds. It sounds like it should, and sometimes it does, and actually super technically, if you're really clear on what averages really mean, then it does. But there's more than one way to take an average, and taking averages of numbers can get complicated when the numbers are more complicated than the eye. Oh, sorry, someone's here. So even if it turns out that we can think of average speed in an averaging sort of way, and even if it does turn out that it's not a coincidence that it's called average speed, like we're not calling it that to trick anybody or something, nonetheless, we have one and only one definition of average speed, and that is total distance over total time. And we found out in the last problem in Hill figure that that is the definition that gets us an answer, and anything else gets us an answer that doesn't make sense, and anything else isn't consistent with the truth of what average speed means. So just like the other one, this is practice in the same exact idea or application of the same idea. Like the average of the speeds is not, sorry, the average speed is not straight up the average of the two speed numbers. It just isn't. So what is average speed? It is total distance over total time. Just like average velocity is total displacement over total time. So I'm going to do step 3 as I'm always. Step 3 is write down general definitions and principles, write down something true, something triple equal sign, from which we will start applying to the particular and plugging in numbers, blah, blah, blah. So if I do step 3, right? This is what I have to write down. It's always true. We're dealing with average speed. That's the definition of it. It may not look helpful, but it's never wrong. It's always point. It's always true. So I'm going to go to the next page. I'm just copying it. And now I'm just trying to be more explicit, just adding the word totals just to really highlight, like just like last time. In other words, right. Sorry. Yeah, actually. Again, I could be using X's here. I'm just trying to use D's right now just to keep it clear that we're talking about distances, not displacements. Eventually, everything's going to be all X's. Also, to keep us versatile, like I hope you understand I'm not making up a new equation. I'm not making up a new formula. I'm keeping the same one and only English definition that we have, and I'm just using symbols to abbreviate it. We want to be that flexible. So I'm saying average speed is total distance over total time. So that means distance out plus distance in over time out plus time in, right? Okay, so let's see what, right? So if we, so we know, and now I'm starting to apply to a particular problem. Okay, now, right, I'm just filling in what I know here to see what I have to solve for, like just to jump, I'm going to turn it to you guys in a second, but I hope you see what I'm doing. Like I'm starting with things that I know is true. Average speed equals total distance over total time. And then I'm filling in to see what it is I'm actually looking for. And maybe I shouldn't have put in the numbers yet. Maybe that's a mistake, but you're going to know, like the fact is I know the distance out, I know the distance in. As far as the times, I guess I'm going to ask you guys, do I know or can I figure out the time out? I'm going to pause here. I'm literally asking you guys. You can think about it for a second. And there's either tell me that we know the time out or tell me that we don't, or tell me, okay, we don't know it, but we can figure it out. Like we have access to it. Or like, does anybody know the amount of time it took to go out, or can anybody figure out? That's really my question. I'll even put it in the chat. Oh, great. Awesome. Wait, okay. I was about to put the question in chat, but I see that. Great. Okay. Yay, Jayla, yay, Rydia, yay, Daniela. First of all, by the way, again, just for the record, each one of those three people has literally said something concrete enough. Just to be clear, Jayla, Rydia, and Daniela have now actually said something concrete enough in the chat. Definitely submit those to the portal that says for right or for wrong. Like notice I'm saying this before I even say whether they're right or they're wrong. Either way, each one of them is going to be one or the other, to be honest, right? Like they're saying something concrete enough that it's not just like they're feeling. I'm not going to be like, oh, yes, I mean, even though that's the way everybody talks about, like, I feel that you made a mistake in step 3, but that's like such nonsense. Like, but what I'm saying is each one of them just took a stab. No matter what I say, wait, someone's here, sorry. No matter what I say, they should each submit what they just wrote into the portal that says for right or for wrong, because each one of them is going to be one or the other. Okay. And again, by the way, they can do it more than once. I only just have the portal up once just to show you, like, you don't have to do it every day. But if they've done this more than once, they can submit it more than once. But just like your video and your avatars and all that. But also, I want to make clear now, before I'm like, they actually put in different answers, these three. And there's still, also notice I'm stalling. So there's still total time for any of you to put in the chat an answer, even if you think it's the same answer as one of them. This is not a race. You know, even if you agree with one of them, I don't care who puts it in first or whatever, right? And I'm not saying what the answer is right yet. So any of you that wants to put in the chat anything now, you definitely then can submit it for, not that the whole world revolves around points, but it does in a class, right? Anyone, to pretend it's money, any one of you could then put this in for right or for wrong. And then I'm going to now like say whether it's right or wrong or what I think. And then ironically, and maybe you'll think this is a little weird, if I say anything that implies that any one of these people is like not exactly right, instead of them feeling bad, like, oh, I just got, oh, damn it. Well, that's the next time. That's the last time I'm going to try in this class. I'm saying if any of them ends up getting a reaction from me right now, like, I'm not going to call them out. But if I now say something that shows that one of them is wrong, then they're going to double dip this contribution into they're going to additionally put it in the portal that says wrong. And they're going to get 11 points for the fact that they were willing to like be wrong in public. Okay. And that again might strike you all as weird. Like, well, wait, what about points for being right? Well, those accumulate like automatically. We all think about it. Like everybody's always getting points for being right. If nothing else, like you get the satisfaction of you knowing that I know that you're right. So so this is like a socialist system when it comes to points. What can I tell you? But okay, all right. So now I've got enough. Oh. Wait, okay. Now also what Jayla just put in. And again, I might be moving slowly for some of you. This might be really boring, but remember, as I'm just sitting here spinning my wheels, you have an opportunity to put anything you want in the chat that you think is related to this at all, even if someone else put it. And that's just points there. So even if I'm boring you, it's just like points accumulation opportunity. But before I respond to, well, okay, first of all, I'm definitely going to say that Jayla's first thing is definitely right. Like you were not, like I'm looking for time out. Let me make that clear. Right now, I'm focusing on time out. And just to be clear, the problem did not explicitly tell us the time out. Yet I do agree that there's enough facts given in the problem that we can, like within one step or something, either in our head or on paper, we can figure out how much time it takes for Little Red Riding Hood to go out, which is what I'm focusing on right now. So I do agree with like Jayla's first thing. Now I'm going to get to Rydia's and Daniela's thing in a second. But one thing now, when Jayla says, wait, professor, on the homework, it says that, because I assume that's like a correction or like an assumption, like a remark that I might be making a mistake. Yes, let me be very clear, or what I think. On the homework, it does say that the average speed on the way out is 40 kilometers per day. It totally does say that. And I think I have that in my fact pattern here. Hold on. Wait. Yeah, like, and I'm not arguing. I mean, like very important observation. And this is why these things can be a little confusing. Like what Jayla is saying there in her second comment is yes. I'm just looking for it. Like the problem does say that the average speed on the way out is 40 kilometers per day. Yet what we're figuring, but it also says, I believe, and I'm not being sarcastic because I'm not like looking at it right now. So you should be looking and seeing if I'm making a mistake or misremembering. But I believe that the problem also says that the average speed for the whole round trip is 80. And we're looking for the average speed on the way back. And I want to pause on that because I don't know if, like, honestly, Jayla might be saying in her second comment, she either might be saying that she thinks I made a mistake. Oh, okay. All right, cool. But to everybody, again, she's not crazy, and that totally counts as a thing that she can put in the wrong portal or whatever. She's not crazy because for many of, and all of this physics endeavor is about trying to bring things from our unconscious mind up to the surface of our conscious mind. I'm not kidding. This is all about what physics is about. Is all about stuff you already know. You just don't know you know, or the reverse, or you think you don't know, or blah, blah, blah. And so one thing that a lot of people don't realize is that it's confusing the first time they consciously face the idea that there can be more than one average for a set of events or a set of numbers. That actually seems contradictory at first. It also often seems at first like, well, there's a bunch of numbers and then there's like an average of all of them. Like, okay, like we got 40, we got 80, and then we're looking for an average. But actually, just like with your test scores in a class, as you get exam scores or grades or whatever in a class, right? You get grade. And then sure, at the end of the whole semester, we say you have an average of all those numbers. But as you guys know, you calculate your average as you're going, right? Like many of you do. Like you have an average after the first 2 weeks of numbers, and that's different. And that's still true. Like, even if you get to the end of the semester, if we want to, we can stop and say, what was their average of their first 15 assignments? Like, not their average for the whole semester, but what was their average for the first 15 assignments? We can look at that, and they might have even known that at that stage. And then we could say, oh, damn, their average was going down. That's disappointing. Or like, oh, yay, their average was going up. Average apply, like there can be as many averages as there are numbers in a situation, because average assumes that you've grouped a subset of your data and you're getting an average for it. So, okay, so in this problem, what you were told is that you knew an average on the way out is 40. You knew and then you came back in at some unknown average, and but we know that the average for the whole out and in round trip is supposed to be 80. And we're trying to figure out what we did on the way in. So, so she said, thank you. So now I'm going to say, I love what Rydia put. I think I get the logic of what Rydia put, and I think it's on the right track, but just to be like totally blunt or move on, I actually want to even specifically agree with what Daniela put. Like if it doesn't contradict, Yeah, to be honest, it slightly contradicts Rydia. So am I going to say, so Rydia's right contribution, but not totally right answer, but she gets 11 points. Daniela is saying that, let me just clarify what my question was. Like, my question to all of you was, like, I'm trying to fill out things. I'm saying all I know, again, all I have is one equation. Average speed equals total distance over total time. So, and I'm trying to break it down. And total in this case means out plus in, like total, like round trip. So what I was asking everybody is, do we know the time out? Like, is that a fact we could fill in? And what Daniela is saying is, yes, we do, actually. I mean, like, we weren't told it, but in effect, we can figure out that it's 48 hours, i.e. she's saying 2 days. And the reason she's saying that, I'm just going to get, I mean, I don't know if she wants to explain, she can, but she's getting that from the fact, basically from Jayla's observation, I mean, from the thing we were just talking about, which is that on the way out, it was 40, excuse me, on the way out, it was a distance of 80 kilometers, but the given speed that we went, that we know we went, was 40 kilometers per day. So literally so maybe she just did that in her head, but it is just, it's the same equation over and over. She's saying, well, I'll write it down. She's saying, look, if you only went 40 kilometers per day, but you had 80 kilometers to go, then it took you 2 days. That's what she's saying. And I agree with her. It's not the answer to this whole question. It's the answer to the question I was asking, like the sub question. She is saying, again, and she, I just told her. Sorry, Daniela is saying, she's saying, dude, get a pen. Okay, yes. Okay, right. So now again, some of you might just see that in your head. Some of you might think that I'm like adding more work than is necessary to see. Like, some of you might think that's totally obvious. So I'm just making this more complicated the way I'm writing out. But I'm also trying to show you that even the stuff that's obvious can be proved. Like, right? Like, it may be obvious to you, but that's because you did a couple of steps in your brain really fast, and they can be shown. But I'm also trying to show you, notice that everything we know about this problem, we're still just figuring out by circling through or doing different permutations of the one concept we have, which is average speed equals distance over time, right? I mean, and the units do work and all of that. It's not like, so this isn't like a new knowledge, or it's not, you get my point. So the time out is 2 days. Now, let me go back. Now, that's not the answer to the whole problem. It's just, I think, a fact that is reducing the number of unknowns if we look at what we're trying to do. So back to this. So we have, So is this fair so far, right? So we're, oh. Right? Like we don't know. So we just figured out the time out. Like Daniela and others just helped us figure out the time out. What we definitely don't know is the time in. We definitely don't know that because it's actually ultimately what we're looking for. Like if we do the same process, like, okay, I guess to be totally clear, yeah. Sorry. All right, just to be as clear, maybe, and as usual, maybe I'm beating a dead horse, which is gross and mean. Sorry, but what I'm just trying to really be clear here that, and I'm trying to show you that even if you don't know something, you can still know what to do, even if you don't know what to do, because you just work with what you got. I'm saying like, okay, the oh, okay, now we're talking. Pretty much yes, I think to jail. I think. Well, sort of. I mean, I think we used the 40 kilometers per day, we used it to get the time out. Like we did it, the 40 we used right here, okay, to get the time out. Now what I'm saying is we would do the same logic. We would do the same logic to get the time in. But we would say time in equals distance in. Oh, okay, no problem. Cool. Okay, but so to everybody, here's the catch now. We want to use the same logic and say time in equals distance in over speed in, but it's the speed in that we are literally trying to trying to figure out, like WIQ, like literally the question is, what is the average speed in? Like that is the question. So what I'm really trying to say now, kind of around the mulberry bush, is, okay. So actually, in a way, like we could look at it the other way. We could say, like the thing that we're actually trying to look for, average speed in, literally will be the distance in over the time in, right? And the distance in is certainly 80 kilometers. It's 80 kilometers. The time in, we don't know. That's the hook. Like if we could figure out how much time it has to take to get in, 80 divided by that would be our answer. What we're really looking for logically here, in order to get the final answer, what we're looking for in order to get average speed in, which is what the question's asking, we need the time in. Okay, and it seems like we don't have that. But remember, Like we don't know the time in, but we do know, the other fact of this problem, and we keep writing it, but we haven't really used it yet, is that the average speed for the whole thing, the whole round trip, the average speed for the whole thing is supposed to be 80. Like the average speed on the way out was 40, but the average speed for the whole round trip is supposed to be 80, right? And average speed means total distance over total time. So I'm just going to go to the next page. In other words, 80, by given of this problem, from the givens, 80, that is illegible, sorry, 80 kilometers per day must equal 160 kilometers over total round trip time, right? Like, or as we were putting on the other page, I mean, if I want to be really specific, in other words, 80 has to equal 160 kilometers over the 2 hours that the 2 days that Daniela told us, plus the thing that we're looking for, right? Like we know, right? I sound like I'm going in circles here. I'm just trying to repeat. Like we actually know, put another way, we know what the total round trip time, we know what the total round trip time must be, because we know the round trip average speed, and we know the outward. I guess I'm saying, if you can either think of this conceptually or mathematically, but what I'm really saying is this. Okay, if you just want me to do the math, here's the math. I have to explain it though. Oh, I'm going to look in the chat in 1 second. Sorry. Okay, it's easy to get so caught up in the math that you don't see what okay, so the math here just says, look, 80 has to equal 160. 80 has to equal total distance over total time. Total distance is 80 plus 80, 160. Total time is whatever it is out plus whatever it is in. We know what it is out from Daniela. It's 2 days. We're looking for what it is in, but we add them together, that's total time. So if you want to just look mathematically, and I'm using question mark to be like my variable name, I'm just trying to be flexible. Like you could call it X, you could call it D, I don't care what you call it, but question mark right now is my symbol for the unknown thing. Also, the reason I'm not using X or D is that question mark stands for the time in, which is not like the final answer of the problem. It's just like the nub of it's the block in the problem, the time in. Again, because we know the time out. The only fact we don't have is the time in. Well, mathematically, I just multiply both sides by 2 plus question mark, and then I divided both sides by 80. And mathematically, what I got is question mark equals 0. What the heck am I saying? Mathematically, physically, what I'm saying is, okay, look, if you want the average, and it's about to be an answer, and then I'm going to look in the chat. Okay, I'm going to look at the chat. Well, I might ignore the chat. Oh, okay. No, there's nothing in the chat. Okay. No. Okay. What I'm saying here is that if we want the average speed for the whole round trip to be 80, that means, if you really think about it just straightforwardly, we want the entire round trip to take 2 days, right? Because the entire round trip is 160 kilometers. We want to go an average of 80 for a 160 kilometer trip. Then this is literally just the logic that Danielle was using before flipped. It's just literally average speed equals distance over time. If you want to go 160 kilometers at an average speed of 80, it's going to take you 2 days to do that. So if we just look at that basic fact of the problem, it's saying, oh, in order for this whole problem to work, in order for us to get an answer, in order for us to get an average speed of 80 for the whole thing, we need the whole round trip to take 2 days. That's what that's saying. That in itself is just math that, or logic or whatever. But then in the other side of our brain, Daniela has already told us, and others, people have figured out, but Daniela already told us, oh, okay, fine, like whatever with that. But, by the way, on the way out, you only had 80 miles to go and you only went a speed of 40 kilometers per day. So, on the way out, you took already 2 days. You took 2 days to go out. And now you're saying, Yaverbaum, or this page is saying, that in order to accomplish the mission of this problem, we need to use 2 days to take the entire round trip. But we just used 2 days to go out. So with this zero here saying, it's not a contradiction, it's not like an error or anything, and it's also not literally our answer, but this zero means what we're saying, we have to do the back trip, the in trip in no time at all for this problem to work. Like that's what it's saying. We're basically figuring how much time do we have left over to do our back trip, given the facts, and the answer is you have no time left over. You just used all of your round trip allotted time on your out trip. That's what the math, that's what the facts are saying. We're saying so I'm gonna finish this and then pause. It's still not technically an answer yet. It's about to be an answer, but like what I think we just figured out, and it's not a trick. It is tricky. It is perhaps even frustrating or annoying, no doubt. But what it seems that what we really figured out is in order to our goal is to figure out how fast we have to travel on the way back in order to accomplish a certain goal for this entire round trip. Or the question we're trying to answer is how fast do we have to travel on average on the way back? What we figured out is our sub goal, like in order to get that answer, really the key, the sub goal, the along the way problem that we have to solve in order to solve the big problem is we really have to figure out how much time we can take on traveling back, traveling in. We really kind of figured out that as long as we know how much time it takes us to come in, then we'll know what average speed we went on the way in, and because we know the distance. So if we know the time, we know the speed. But what we've just figured out is the amount of time we have in which to make our return trip, our in trip, the amount of time we have left over to do that is 0. We needed to use 2 hours. We only have 2 hours to work with for the whole round trip, but we used up the 2 hours on the way out. So we've got nothing remaining time-wise for the trip back in. Therefore, if we're looking for an answer, if we're looking for how fast must we travel on the way back in order to get an answer to this whole problem, what I'm saying is the answer is not 120. The answer is not 160. The answer is not 800. The answer is not the speed of light. If there's an answer to this question, and I think there is, the answer to this question to be both technical and proper and or accurate or whatever. I'm saying, and again, you might say this is obnoxious. Maybe it is. I'm saying the answer is infinity, or the answer is the limit as speed approaches infinity, if you want to say it more in a calculus way. And we do have to get into calculus and stuff like that. Like physics does deal with infinity. This is intro to that fact. Physics, just like physics can deal with things turning around in an infinitely small amount of time, and that's not a contradiction, it's not Smurf Village, it's not idealization. It just means we deal with things that are so small in quantity that they can't be measured. Therefore, we can call them infinitely small. Also, we can deal with things that are so big that they can't be measured. We call that infinitely big. Let me back up for a second too. I'm a little defensive about this because you might feel like this is an obnoxious problem. I'm saying the answer to the problem is infinity speed or infinite speed. Now, two things about that. One, am I saying that that is practically possible? Do I have cars that go infinite speed? No, I'm not saying that. In other words, you might even argue, and you could put, if this were on an exam question or something like that, you could say that the answer is, it is impossible. It cannot be done. GrammaGrimm, or I mean, Little Red Riding Hood would require infinite speed in order to accomplish this. And no cartoon character or object or even particle of light can go infinite speed. You could say that. You could say the answer is it cannot be done. The answer is that the speed required would be an infinite speed and nothing goes in infinite speed. Totally legitimate answer. Okay, a totally legitimate way to put it. Like the answer is it can't be done. But make no mistake, that is the answer. That doesn't mean that this question can't be solved. It doesn't mean that it's an unfair or illegitimate question. It doesn't mean that there's an error in the question. If I change the number slightly, we would get literally, if I change the number slightly, we would get a slightly less psychedelic or weird answer. We would get a numerical answer. We happen to pick numbers that if you run through the numbers and you do the standard procedure, you find, oh, that's odd. Oh, it seemed reasonable. It seemed like she went out at 40. She wants to, and she's got to come back. And we want the whole thing to average 80. So we're asking how fast does she have to come back? It kind of seems like it should be 120. But if you plug 120 into the procedure I just did, you'll find that's not fast enough. Like she won't come back in enough time to, like, let me even say this a different way. If you just plug in the first numbers, you'll see she has 2 hours to do this entire round trip. That's definitely what the numbers are saying. Now, if you try 120, she's going to take more time than she has to come back. If you try something higher, like 160, that's still not good enough. Try 200, it's still not good enough. What you find is that there's no number good enough to satisfy this requirement. If we change the number slightly, then there would be a number good enough. In other words, this question can be answered, and it can be answered with the exact standard procedures that we have in front of us, the exact standard definitions, and nothing more is required. But if you run the standard definition or the only knowledge you have, what you find is, oh, this is kind of a head scratcher of a funny situation. Who would have guessed? But in fact, in order to come back and average out for 80 kilometers per day for the whole round trip, she would have to come back at infinite speeds. That's a concept that is workable in physics and math. It's not workable in the technological world. So she can't do it. That's the answer. Doesn't mean the question can't be asked. Doesn't mean that it's an illegitimate question. I mean, I know it might feel that way. And yes, it is a tricky question. And would I put something like this on an exam, just fresh up like this out of nowhere? No. The only way I would put a question like this on an exam is if it were like a different version of something we had practiced, like if it were like this, but tweaked, so you had seen it before. So it is a homework question to get us to think and stuff. But it's, again, to reinforce the idea, like, what is the bottom line of all of this? Well, first of all, the first thing is infinity is allowed in this class. We're going to get into infinity and infinitely small. That's why you have to have some calculus background to take physics. Infinity is part of physics. It isn't necessarily part of cars and airplanes and like macroscopic classical objects, but it is part of physics. But number two, the real point of this question is average speed does not equal the average of speeds. Average velocity does not equal the average of velocities. It equals displacement over time. Rydia, great question. I've only seen part of it, but I think I know what the rest of it says. Yes, there is not yet. I will give you a date for that soon. I mean, totally fair question. We don't have a first exam scheduled yet. Let me tell you all, since you've never had an exam with me yet, you don't know how it works yet. I can understand why you'd be concerned. I don't even schedule the first exam until I think we're like sort of in a position to be ready to take it. Like, I want to give you back homework stuff. Also, I generally schedule the first exam with a little bit of input from the group. Like and we're getting close to worry about that. All right, let me actually pause. Wait, hold on. I'm going to answer Rydia's question in more detail in a moment because I know we're concerned about that. But so I will, wait, in fact, let me look at the time. Hold on, this ends at 12:05. All right, we're not going to get very far in homework 3, but that's okay. This is a lot. We may end up spending the rest of the time maybe on Rydia's question. I'm not sure. But before I say a little bit more about Rydia's question, is this clear? Like, is everybody, I mean, I don't want you to feel tricked. At the beginning, physics can feel tricky, like I'm asking you obnoxious trick questions. There is always something tricky about physics. But what we're trying to trick you into seeing at first is the trickiness is that the basic principles, that the basic definitions are much more powerful than they might seem, and that it's really incumbent upon us to stick to them. It's very on purpose. I know some of you have had physics before in high school and you've seen a million equations already. I'm very on purpose trying to give very few equations at the beginning because I really want you guys to see it's not about memorizing a million equations and it's not about choosing which of a million equations to use at which time. It's about generating a lot of knowledge from very few pieces. That is what physics is about. Oh, okay, so it will speed up. We will get more equations and stuff. But if ever you feel like something tricky is going on in physics, go back to basics. Don't think that we're expecting you to do something new if something seems tricky. We're asking you to remember something old. All right, let me look at this chat question. Hold on, I see. Oh, yeah, totally. Yes, Alyssa, yes. If you show the work on this and you ultimately put either infinity, like infinity kilometers per day as the answer, or cannot be done, yeah. As long as, what I guess I'm trying to say to everybody is you can write as your answer cannot be done, totally acceptable. Just like sort of like in math when you get divided by 0, sometimes people say that. As long as it's clear to you and clear to me that you're not saying that this question can't be solved. You're saying that the solution to this question, or that this problem can't be worked out. You're saying that upon working out the problem, you find that the answer is Little Red Riding Hood cannot do it, right? It's not I cannot solve the problem. It's that the solution to the problem is there is no finite speed big enough to accomplish this task. So yes, you can, if you write infinity or cannot be done, those are absolutely 100% acceptable answers, yes. So I'm going to take Alyssa's question to be like, I mean, is everybody cool if that's the answer to Alyssa's question? Like, okay, cool, thank you. And that she just got points for closing a conversation. And is everybody, now I'm going to go back to Rydia's question because, and it's not a surprise to me that Rydia just asked what she did. Like, hopefully you are all thinking like, all right, I get it. You might be a little, I mean, I don't mean to crush anybody's spirits. I definitely, when I first saw this question, especially at the beginning, I was like, oh, great, this is going to be that kind of class. Like, I thought it made sense. Yeah, I see how it makes sense, but God, that's like obnoxious. Like you might be thinking that. And so then you might be thinking, well, I guess I get it, but like, I don't know what I would do the next time a question like this comes up and like, oh my God, like, is this going to be like, are my grades dependent on questions like this? What does it deal with the exam? Like, it's not a shock to me that exam would then come up after this, but as long as that's what you're thinking, if all of you are like, yes, I get it, but I'm not sure what I would do the next time, or I'm not sure what now I'm a little worried about my grade. Fine. First of all, don't be, just keep staying with me. But all right, I'm going to I might as well spend the next 4 minutes talking about how exams work. Bear with. So we will start on Wednesday going right with train of thought. If you have done train of thought and you have not gotten it back, that's correct. I mean, you haven't. If you've done it, you're good. Just have it prepared, like maybe refresh, look at it before Wednesday. If you haven't done it, you can still do it. And please do. So you know what we're talking about Wednesday. Wednesday is going to be a deeper probe into what speed and velocity mean. And you're going to feel like this is less and less obnoxious, hopefully, as we go. But now, so therefore, I'm going to spend the next 3 minutes answering Rydia's questions about exams. I have not announced the next exam yet. Fairly soon, like in about a week or so, once we've had like a couple of full weeks class, I will probably come to you guys at the beginning of class and I'll say, I'm thinking that the exam is going to be blah, like this coming 2 weeks from now, 3 weeks from now, like, and you will have that much notice. So 2 weeks from now, and I'll say, does that work for you guys? Or do you all have an organic chem test that day or something? Like, I'm going to ask you guys. And if I can't necessarily do it by full consensus, but I will get your input. And if all of you are like, wait, can you just postpone it by 1 day? Can you not make it that day? And we can get through Orgo. And I'll be like, yes, that's fine. Okay. So first of all, there's not going to be a surprise. Second of all, let me also make clear, and maybe you should be writing this down. I think this all says this in the syllabus technically, but I also want to make clear that one reason we haven't had an exam yet is that usually, especially these days with Zoom and everything, usually there's one midterm in this class and one final. So the midterm is around the middle of the semester. There's not two midterms, there's one. Okay, so I like to make some degree of tracks before we get to that midterm. The midterm is not going to come to you as a surprise. I'm going to come to you and say, in about 2 weeks, we need a midterm. I think I'm proposing this date. You'll tweak the date with me. You'll have about 2 weeks before that midterm comes. Then I'll officially put it in Google Classroom and all that. But let me also tell you, since there's 2 minutes left and since Rudy is asking, here's how midterms work. Once we fix a date for it, first of all, what you will get from me, not that night, but you'll get a practice exam from me. You will get an exam that basically that in format and structure and everything looks identical to what your actual midterm will be. It will be like 85% identical to your midterm, but your actual midterm, like some things will be changed. Like, and it would be like 3 problems. It would be like 3 homework assignments, kind of like a fact pattern, and then like question part A, part B, part C, part D, and then another problem. Problem 2, fact pattern diagram, part A, part B, part P. Okay, like that. You'll get more and more used to these problems before you do the midterm, and you'll get a practice midterm that's almost identically is your midterm. It's just that your midterm, some of the numbers will be changed, and like part D will be of this thing will be changed, but you'll get a practice test that will look a heck of a lot like your actual midterm. And before you actually take your midterm, we will have answered questions about that practice test, and you will even get some solutions to it from me. Like you'll get a chance to work on it on the practice test on your own, at home, with each other. I won't right away, but I will eventually, before your actual exam, post solutions so you can see if you're doing it right or wrong, whatever. I'll answer questions about it in class, like review, and I'll answer, like you could say, wait, I see how you did problem 3, but I don't get why do you have a minus sign here, Yavram? And I'll answer that in class. So you will have a practice exam largely with solutions that you will be able to walk through to some extent before you even take the exam, and you'll be able to walk through with me. Okay, just so that you all know, an exam is not going to just drop from the sky and then just suddenly put you on the spot. But last thing, I see it's 12:05, so we're just about to be done. I also want to tell you that even after all that, and once we say our exam is 3 weeks from now, Wednesday, it's going to be a take-home exam that you're going to take home, and you're going to do, and you're like over 3 days or something, and you're going to submit to Google Classroom as though it were an assignment. It's just a big assignment that's worth 100 points. And it's not going to be timed, and it's not going to be with webcams or anything like that. I'll give more details on Wednesday, but I'm not saying it's going to be easy. And I'm not saying everybody always gets 100 on it. They don't, it isn't, but it is take home, and there will be no surprises on it. And you will be allowed to do it on your own time with whatever resources you want. So it's not easy, but there won't be surprises. And the hard part will just be the physics, not any extra unnecessary academic stress. Okay. So it won't drop out of the sky on you. We will be talking about it and preparing for it before it happens. But that'll be in a couple of weeks. Okay, great. Okay. Thank you guys. Okay. So I think that's class. So I'll hang out for a second if there's any questions, but thank you all very much. Like goodbye. I'll see you. Thank you. I'll turn off the recording. Okay, awesome. Good question, Rudy. Does that answer it, Rudy? Okay, so cool. Thank you. Cool. Thank you, guys. Yes. Okay. Good. Thank you. Okay. Cool. Bye. Yes. Bye. Okay. Cool.